Let's go ahead and begin our second of our 5 review lessons. Today's topic is factoring. So, some basics to start. You are expected to know how to factor a difference of 2 squares. You, of course, can put the factors in either order. So you can have x plus 4, x minus 4, or you can have x minus 4, x plus 4. And if this were a plus, you couldn't do a difference of 2 squares. It does have to be a difference, and you need perfect squares for both terms. Here's a trinomial, and this is in the form ax squared plus bx plus c, even though the variable is different. So be prepared for different variables next year. So in order to factor this, we start 2 sets of parentheses. We want to see what multiplies to negative 30 and adds to negative 7. That's going to be 10 and 3, where 10 is negative and 3 is positive. I would think at this point you're probably doing that in your head without writing this down. Just about as fast as I did it there. Sometimes I'm a little slower, sometimes a little faster, but you should be pretty fluent with both of these types of factoring at this point. Okay, next one. This has the coefficient in front of the x squared. So this is usually our least favorite type of factoring. But when you see these next year, they're almost always going to have like a 2 or a 3 in the front, maybe a 4. And the 2s and 3s are good news because when you go to factor those, the only way to factor 2x squared is with the 2x and 1x. Or if you had a 3x squared, it's just 3 and 1. You can't, there are no other factors. Since 2 is prime, it's only 2 and 1 that you're going to break that down into. So you shouldn't really need a process for this. Since this is such a nice number here with just the 2 factors, you should be able to fairly quickly guess and check to find your answers. Because when you see that the last term is positive, but the middle term is negative, you should realize that means that both of these are going to have minus, because that's how you multiply to a positive but add to a negative. And then 3 only factors to 3 and 1. So it's either 1 here, 3 here, or 3 here, 1 here. So with a quick check of your outers and inners, you will see that this is going to give you minus 1x and minus 6x, which gives you the minus 7x in the middle. So your factorization is this. I wrote the 1 in front of the x. You can leave it as 1x, but usually we just write the x instead. And you can always check your own factoring by foiling, and you can do that mentally or on the paper. For number 4, you should be fluent with this type of factoring as well. When you see 4 terms, you should think grouping. So 4 terms, you want to think grouping. The GCF of the first 2 terms here is m squared, leaving us with m minus 4. Here we have to match the m minus 4. In order for this to actually factor by grouping, that has to happen. If that doesn't happen, then we can't factor by grouping. So what we can take out here is a minus 6. So if I take out a minus 6, because 6 is the GCF of these 2 terms, and since there's a minus here, I'm going to keep that minus. So when I divide this by negative 6, I'm left with m. When I divide this by negative 6, I'm left with minus 4. So I take my 2 GCFs and my repeated expression and use it once. So this is my final answer. This does not factor further. It almost looks like a difference of 2 squares, but 6 is not a perfect square. So this is completely factored. Continuing on. Sometimes when you have a difference of 2 squares, the number comes first. That's okay. So I would just factor this as 5 plus y, 5 minus y. Square root of 25 starts both, square root of y ends both. And it should be about that quick to factor that one. There are other ways to do this. So I'll mention that in the practice problems video, because this is the way I'd like you to factor this. But for anyone who is possibly thinking of factoring that a different way, you can look at one that's very similar in the practice problems video. Here's another one where we have an ax squared. We have a term in front of the x squared term. I know the variable here is a, but this is still the form ax squared plus bx plus c. So the a's here are taking the place of the x's. So to factor this one, we're going to have 3a and 1a. So once again, since 3 is prime, it's pretty nice. That's the only way to break down the 3a. 10 can be broken down different ways. It could be 1 and 10 or 5 and 2. But we have some extra clues here. Since this is positive and this is positive, they're both going to be positive. That's the only way you're going to multiply to a positive and add to a positive. So thinking about 1 and 10 and 2 and 5, if I put 1 here and 10 here, you should see pretty quickly that doesn't work. because there's no way 30a is going to come up to 17a here. If you try to put a 1 here and a 10 here, you'll get 10a and 3a. That doesn't make 17. So we need to use 5 and 2. And when you take a look and see that you're going to be using 5 and 2, you just have to decide 2, 5 or 5, 2. So if I put the 5 here and the 2 here, that's going to work nicely because that'll give me 2a and 15a. So my factorization that I'm looking for is 3a plus 2a plus 5. Okay. So those are types of factoring that you did in Algebra 1 and again in Algebra 2. The next problem, number 7, I don't think you may have seen that in Algebra 1, but you not as much as this year. So this is still the form of an ax squared plus bx plus c or 1x squared plus bx plus c. Because we have a term where the variable is raised to the fourth, a term where the variable is raised to the second, and a constant. So it's the same form or structure as this. So the way we did this is we said, okay, to get t to the fourth, let's break that down into t squared and t squared. We don't want t to the third and t to the first because the outers and inners are supposed to add to this term here. So we want t squared, even though it's not the only way to get t to the fourth. And then we say, what do we multiply to get 20 and add to -9? So what we're looking at is -5 and -4, because that's going to multiply to 20 and add to -9. Now for this one, we're not finished because there's a difference of 2 squares here. So t squared minus 5 can't be factored, but t squared minus 4 can be factored into t plus 2, t minus 2. And that is your complete factorization. Okay, and again, the factors can be written in any order. So if you want to write this one, then that one, then that one, that's fine. It can be t minus 2 first, then t plus 2, then t squared minus 5. All those variations are correct. Number 8, that's one that you've been doing since Algebra 1 for sure. We don't see it that often, but when you have a negative out front, usually we don't like to factor when there's a negative for the leading coefficient. So if we factor out a negative or a -1, that's going to change all the signs inside. So if I factor out a -1, what I'm going to have in the parentheses is positive x squared minus x minus 12. And by factoring out that -1, we now have a positive leading coefficient of x squared, and that's what we like. Because now we can set up our two factors, what multiplies to -12 and adds to -1. And there's a good answer. If you don't have to write the negative. So I'm sorry, you have to write the negative. You don't have to write the 1. So you can just have the opposite of these two factors. That works just fine. There are ways to factor this straight away using a -x and an x. I'm not going to show that in this video because this really is preferred. To factor out a -1 is really what you're going to want to do next year in pre-calc most of the time when you see a negative leading coefficient. So if you're interested in this, I'll bring that up in the practice problems video. And one thing you may notice that's missing is I have not brought up the sum and difference of cubes factoring. We did cover that this year. That was a new method this year. You probably won't see it next year. It's not something that comes up very often. So if it did come up, we would review it with you. So I'm not even going to do one. We have 3 more to go. Okay, now I'm stepping it up a level here. We did very little with multivariable. We did very little this year with multiple variables. But next year, you are going to be expected to apply your factoring to some things that are a little tougher, that the structure looks a little different. So if we look at x to the fourth minus y to the fourth, maybe you'll see that it's a difference of 2 squares. So we can factor that as x squared minus y squared, x squared plus y squared. Because what we do is we take the square root of the first term, which is x squared, and the square root of the second term, which is y squared, and we use a minus in one factor and a difference in the other factor. So that's the first step. This does actually factor further because we have another difference of 2 squares right here. This is going to be an x to start both, a y to end both. One's a plus, one's a minus. And then we have an x squared plus y squared. So that's our complete factorization. The next one also has multivariable. Since it has 4 terms, even though we didn't do a lot with multiple variables, when you see 4 terms, you should think this might be grouping. So if we look at the first 2 terms, what they have in common is x squared. And if we factor that out, we're left with a y minus 5. The next 2 terms have a 3 in common. And if we factor that out, we get a matching expression. If we didn't have a matching expression here, then grouping wouldn't work. Grouping doesn't always work, but when it does work, you get those matching expressions. So you take those 2 little GCFs, they make one factor, and the repeated expression makes a second factor. This one does not factor any further. And our last one, here we have m's and n's. So this is only 2 terms. It's not a difference of 2 squares. It can't be grouping because it's only 4 terms. This is just GCF. I didn't throw that into the other problems, but we do want to check for GCF first because sometimes we have them. So looking at these 2 terms, that's 1 term and second term. What they have in common is m squared. So if I factor out an m squared, I'm left with m minus n squared. And that does not factor any further. So that last one with just the GCF factoring was actually pretty quick, but maybe kind of unexpected because we hadn't seen GCF yet today. All right, so that's it for the review video. Just a quick reminder, not every expression is factorable. So in the practice set, I did throw one in that doesn't factor, so just a warning on that. And now you can continue on to the practice. Thanks, guys. Bye-bye.